Hello and welcome to the Math Studio. In this video, we're going to look at some examples involving angles on the coordinate plane. So this is angles and trigonometry beyond just quadrant 1. So the angles could be anywhere from 0 to 360 degrees or even negative angles for that matter. So let's have a look at example A. Find cos of theta given sine of theta equals 1 on 5 for theta between 0 degrees and 360 degrees. So looking at the ratio sine of theta equals 1 on 5, it's positive. So that means that sine of theta or theta itself could be either in quadrant 1 or quadrant 2. So I might just draw a quick diagram here so we can just quickly visualize what's going on. Okay. So 1 on 5, that's opposite over hypotenuse. Okay, so opposite might be 1 unit and the hypotenuse is 5. Okay, and there's our theta in there. Sorry, it's only a very small diagram, but just sort of imagine there's our theta there. Okay, so we want cos of theta. Okay, now that means then that if sine of theta is either quadrant 1 or quadrant 2, given that 1 on 5 is positive, then cos of theta, there's going to be two values for that. Quadrant 1, cos of theta is going to be positive, but quadrant 2, so I'll just sort of write this down there, quadrant 2, cos of theta will be negative. Okay, so the first thing that we do though is look at the related acute angle. So what I might do is I might just draw the triangle sort of separate to the coordinate plane, just so we can see what's going on here. We're going to use Pythagoras theorem, of course, to find the adjacent side. Sine of theta equals 1 on 5, so that's opposite over hypotenuse. Okay, so that's 25 minus 1, 24, square root of 24 is 2 root 6. Okay, so I might just do my working out here. So sine theta equals 1 on 5 implies that theta is in quadrants or quadrant 1 or quadrant 2. So quadrant 1, okay, cos of theta is going to be positive, okay, and that's going to be equal to 2 root 6 over 5, okay, and in quadrant 2, okay, cos of theta will be negative, of course. You've got all stations, right? Only sine is positive in quadrant 2. So cos of theta is negative. So the other possibility is negative 2 root 6 over 5. So back to this diagram there, and I might just use a different color. That's a triangle, in fact a congruent triangle, the same triangle but drawn sort of reflected in the y-axis like this, okay, and that's 1, but that's 5, but this is 2 root 6, and this one will be negative 2 root 6 there. Okay, so there's our two values for cos of theta. So therefore cos of theta, we could actually combine the two solutions there, is really plus or minus 2 root 6 over 5. All right, let's have a look at example B. Okay, so find tan of theta given cos of theta is equal to negative 3 on 5 and tan of theta is positive. Okay, so first of all, tan of theta being positive, that means that theta, actually I'll just write this a little bit differently, theta is in quadrant 1 or 3, all stations 2 central, so that's 1 and 3. And cos theta being negative, okay, so I might just write that there, so cos theta being negative, that means that theta is in quadrant 2 or 3. Okay, so with these two conditions, the one condition or the one thing that's in common is that tan of theta is in quadrant, or could be in quadrant 3, but cos of theta could also be in quadrant 3. So the two things that are in fact in common between the tan theta and the cos theta is in tan theta positive, cos theta negative, is that the theta must be in quadrant 3. Okay. Okay, so if theta must be in quadrant 3, so obviously that means that we know that tan theta obviously must be positive. So we can draw our triangle. And I'm just going to draw the triangle as if it was in quadrant 1. Okay, so cos theta is equal to negative 3 on 5. Okay, so that's an adjacent side of 3, 5. Now, this triangle's not drawn to scale, of course. We can use Pythagoras theorem, and we end up with 4 there. So tan of theta, and we know it's going to be positive anyway, is going to be 4 over 3. Okay, and our last example, okay, if cot theta is equal to square root of 11 on 5, find cosec theta. Now, again, this one has two possibilities. Cot theta, as you know, is the reciprocal of tan theta, or sort of defined as cosine of theta over the sine of theta. But cot theta is positive in quadrants 1 and 3. So therefore, cosec theta, which is 1 on sine theta, would be positive in quadrant 1, but negative in quadrant 3. So, okay, so okay, so we also know that cosec theta, okay, is positive in quadrant 1, and cosec theta is negative in quadrant 3. Okay, so we can draw our triangle again, and it always helps to visualize it with a right angle triangle. And again, this is where Pythagoras theorem really comes in handy as well. And this is where sort of trigonometry meets Pythagoras theorem. And so they're sort of used in tandem. Okay, so I'm just going to quickly sketch a triangle. Hopefully I've got enough space here. Okay, so we have cot of theta is equal to root 11 on 5. Now, if tan of theta is opposite over adjacent, so cot of theta is adjacent over opposite. So there's our theta, adjacent over opposite. Okay, now cosec that's hypotenuse over opposite. So using Pythagoras theorem, so let's say call that x there. And just quickly, x is equal to the square root of 11 plus 25, and that's equal to 36. So x is equal to 36, so that's going to be the square root of 36, which equals 6. Okay, so x equals 6. So therefore, cosec theta, and there's going to be a positive and a negative answer. So cosec theta really is plus or minus, okay, hypotenuse over opposite. So cosec is cosec is 1 on sine. Sine is opposite over hypotenuse, so the reciprocal of that is hypotenuse over opposite. Okay, and so that's going to be 6 plus or minus 6 over 5.